Sometimes there are a lot of different possible outcomes. Sometimes they're really pretty great, and sometimes you think to yourself, what could possibly go wrong if I do this? Well, today we're going to go ahead and explore a few different probability models for multiple events, meaning when one thing happens and another thing happens, what are the different possibilities that could happen? And because it's in October and pretty close to Halloween, this is going to be the Halloween edition of probability. Alright, so it's trick-or-treating night, and here is the street that you live on, and in the first house you have a Frankenstein, and in the second house you have a super scary witch, and in the third house you have a super terrifying dentist. Dentist. And they decided to team up and be like, hey, all these kids come every year, and Frankenstein scares them, and the witch scares them, and the dentist scares them. So let's give them treats that we think we'll like. So Frankenstein says, I'll give them brains. And the witch says, I'll give them apples. And the dentist says, I'll give them cavities with all this candy. And because they usually scare all the trick-or-treaters, they decide, hey, let's all put all of the same things in all of our bags, so that way every single person will like our awesome ideas of brains, apples, and candy to give them. And then they can pick. As a trick-or-treater, I'm terrified of dentists, and I hate how they always give out apples. So, I'm only going to go to one of the houses, and I want to know what's the chance that we'll get apples from the dentist if I only go to one house. So if I'm going to only go to one house, I am going to draw the options that I have. So there, I'm going to make a little box. And this is called an outcome grid or a probability grid. There are 3 different houses I could go to, so I'm going to divide the box into 3 equal sections. 1, 2, 3. And I could either have gone to Frankenstein's house, the witch's house, or the dentist's house. And at those houses, I could have gotten one of 3 different kinds of treat. So I'm going to divide my box the other way into 3 different equal size spots. I could have gotten brains, I could have gotten apples, or I could have gotten candy. And then I'm going to fill out the grid according to these different options. So if I went to Frankenstein's house, in the first option, then I would have probably got either brains, apples, or candy. If I went to the witch's house, I would have gotten brains. Witch's house, I could have gotten an apple, or if I went to the witch's house, I could have gotten candy. And then the dreaded dentist, I could have gone to his house and gotten brains. I could have gotten an apple, or I could have gotten some candy. All of these things have an equal chance of occurring, so there are, if you just count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 possible outcomes, so that goes on the bottom of my fraction. There is only one chance here that I'm going to go to the dentist and end up with apples, so that is 1. So my probability of going to the dentist and getting an apple is equal to 1/9, and that's using an outcome grid. So to summarize, for an outcome grid, you're going to start by drawing a big box. Then you're going to list the possibilities of each event on the sides of the table. Then you're going to divide the rectangle into even sections for all outcomes. And then finally you complete the grid inside the table. So quickly, if I was doing flipping a coin and rolling a dice, and I wanted to know the different combinations, I would put dice on top. 1, 2, 3, 4, 5, or 6. Those all have the same chances of happening in a dice. And then if I was going to flip a coin, it's either going to land on heads or tails. So I say I only have 2 options, so I'm going to divide it accordingly like this. And then I would fill it out. I would have heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, and so on for tails. And I can quickly see that the probability of me getting heads and an odd number would be 1, 2, 3 out of 6 times 2, which is 12 total possibilities, and that simplifies to 1 out of 4 chances. Thank you. Bye. Happy Halloween.